Bismillahirrahmanirrahim. Welcome back, my friends, to my YouTube channel, Drilling and Workover. This is Abdelaziz Gabr. I am accredited instructor in IWCF well control and IADC well sharp. I am also accredited in the mod engineering for basic and advanced mod school. Yesterday, we have talked about the killing procedures. And today, inshallah, we will talk about very important and in my opinion, this is the most important lesson in the course. It's called how to solve the kill sheet. How to solve the kill sheet? We have in the IWCF supervisor level two types of sheets, the vertical sheet and the errors in the reading of the gauges, or it's called the horizontal sheet. So today we will take the vertical sheet and how to solve it, and after this we will take the killing method like the driller method and the weight and weight, and after this inshallah we will talk about the readings in the errors in the reading of the kill sheet. Today we will talk about the vertical sheet. Vertical sheet or the kill sheet, as you see in the picture, it is composed of two pages. Mainly, it is one paper of two pages, one in the side and the other in the back side. So these are the sections of the kill sheet. As you see here, you put the date, the name. All this data will be given to you, and you have to answer the kill sheet to get the requirements from you and put it in the answer. By the way, plus or minus nine requirements are required from you, so that with 3 marks in each one, so it is 27 marks if you solve the kill sheet correctly. So you have to pay attention to every word I will say today. First of all, this is the current well data. Okay, let's go with another with example so you can take review about the issue about the kill sheet. Here is the data of the bumps that will be added. Here is the mass data. Here is the data of the well. Here are the length and the capacity and the volume, the strokes. All of this is are the strokes. Here the shut-in data, shut-in casing pressure, shut-in dreadle pipe pressure, shut-in casing pressure, and bed gain. Here to calculate how to calculate the kill mud weight, and here how to get the initial circulating pressure, and here to the final circulating pressure in order to kill the well. So we will go directly to with an example. This is here also you have to know something. Here in the kill sheet, there is no answer can be correct or not correct. It is correct or not correct. So if I told you that the mud weight is 13.85, for example, and you have to round up, for example, 13.9, but you round down 13.8, it will not be it will be wrong. So here you have to take care of what's rounded up, what is rounded down, what is full number, what is decimal number. So each word I will talk today, you have to pay attention to it. Here some values in the kill sheet, so you have to know if this to be rounded up or rounded down. The depth in feet, you have to put the number. There is nothing called, for example, 1000.5 feet. There is nothing like this. Okay, so it is total number 1000. It's 1000. Pressure in PSI. Also, it has to be full number like this. For example, 500 PSI. There is nothing called 500.5 PSI. There is nothing can be read through the gauges zero point 0.5. How can you read zero point 0.5 in the gauge? It will not be accepted value. So it is also full number. The kill mud weight. You have to take care while calculating the kill mud weight in PPG to be one decimal abbreviated, one decimal. For example, if it is 13.9, 13.85. Okay, to kill the will, you need 13.85. So if you rounded it down, so it will be 13.8. So the will continue to flow. So that it has to be rounded up. So the best answer to be 13.9. So 13.9 is the best answer here. And so that the kill mod weight has to be rounded up. The maximum allowable mud weight, which means the mud weight that the formation can withstand without fracturing. So the more than that value means the fracture of the formation. So that we have to make it round down. So for example, 13.85. If it at 13.85, the formation is okay. So 13.6, so 0.86 means that the formation will be fractured. So you have to take care and put in mind that the maximum allowable mud weight for you to use in the section, you have to be rounded down. So it will be 13.8 is enough. Okay. The capacity is barrel per feet and it is until 4 decimal. There's no problem about this. Take all the number on the calculator. No problem of it. Okay. Volume and barrels. In barrel, you can put all the number, but it's preferred to take to just 2 decimals. For example, quarter of the barrel, 0.25. It's okay, but you can. I don't think you can get more than that, but it's okay, acceptable. If you took all the number from the barrels, it's okay. If you take for example, 500.25, it's okay. 0.256, it's okay also. So there is no problem about this issue too. Strokes. The strokes must be full number. It can be round up or round down. There's no problem about this. And in the exam, there is 20 strokes range. So you have 10 up and 10 down. So at any time, there is no problem. There is no problem. Oh, if you make round up for the strokes, it's okay, no problem. If you round down for the stroke, no problem. But you have to put it in the sheet as a full number. FCP, which means the final circulating pressure, which is the pressure that you have to pump, to keep pumping with it until you finish killing the wheel with the kill mud weight. So FCB and BSI, it's all number. It has to be rounded up because if it is rounded down, it means you will get second gain. So the FCB must be rounded up and take care of this point very much. MASP or maximum allowable annular surface pressure and PSI. MASP it has to be as a pressure all number, but it has to be rounded down because if the MASP is exceeded, for example, the MASP 1000.5 means that this is a mass. If it becomes 1000.6, that will exceed the mass and the formation and the fracture will happen to the formation. So that we make round down, so it will be 1000 is enough. 1000 is enough. The pressure reduction, which is the schedule you make in weight and weight method, and weight and weight method is PSI per 100 stroke. So it has to be put as a number, a concrete number. There is nothing called to 1.6 stroke each 100 PSI, sorry, to 1.6 PSI each 100 stroke. This is not acceptable. It has to be concrete or total number. So it has to be rounded down. So it has to be 221 stroke PSI each 100 stroke. So take care of all these points that and what is rounded up, what is rounded down, and all these points. Time in minutes. There is nothing here called 1 minute point 5, 1 minute point 6. Nothing called like this. It's concrete number and it has to be rounded up to give you more time about the killing. So it's very important question. Now there is data, okay, of a will, and we will revise it and we will see how to solve the kill sheet. The whole size is 8.5. The whole depth, true vertical depth and measured depth is the same. So it's 11,536. Casing 958, true vertical depth by measured depth is the same also. 9875 feet. The drill pipe capacity 0.01741. Heavy wall drill pipe depth or length. Heavy wall drill pipe length is 600 feet, and its capacity of the heavy wall drill pipe also it is 0.00874. Drill collar it's 880 feet, capacity 0.00492. The drilling fluid, which means the current mud weight, the drilling fluid, which is the current mud weight, is 14 ppg. And what is the capacity between the open hole and the drill collar? This is also another capacity, and we will talk about all this now. The capacity on the open hole collars is 0.0322221, and here the other issue capacity between the open hole and drill pipe, capacity between casing and drill pipe. Uh, Fracture fluid density, which means that the maximum allowable mud density. It is the same meaning. Fracture fluid density means the maximum allowable mud density. And here the shut and drill pipe pressure 530 and shut and casing pressure 700. The pump displacement, which means how many barrel per stroke, or pump output, is the same meaning. Pump output, which means 0.10159. Slow circulating pump rate at 30 stroke per minute. Take care of this number. It's 650 and the bit gain is 10 barrels. So all of these data will be put in the kill sheet and we will check for something and we will know how to solve the kill sheet now. This is the kill sheet. Take care of everything. We will talk about this and now. Here the data of the well. This is the true vertical depth of the pit, which was here 11,536. So we put it here 11,536, and the measured depths also are the same. So it is here, and its size is 8.5. Also here the last casing data, which was 958. Okay, here, and the measured depths and true vertical depths are 9875. So here the casing show or the is 9875. So this is very important also, and we put it here. The current mud weight is 14 here. As you see, current mud weight, the drilling mud density here is 14 bbg. So it's put here in order to keep everything. So this section has been finished. Okay, don't pay attention to it now and let's go to another one. Here's a surface leak of pressure. Sometimes he doesn't give you the maximum allowable drilling fluid, but he gives you the surface leak of test. So if the question gives to you the surface leak of test, it will be put here as A and the drilling fluid as the test is number B, and you can make the calculation as here like B plus a divided by true vertical depth multiplied by 0.052. So, but he gives you here directly the maximum allowable drilling fluid or the fractional drilling fluid, which is 16.9. Here, that's it, 16.9. So that's great. And uh, from this one, you have okay. By the way, what are the requirements that's asked from you? He asks always about the strokes here, the strokes to the bed, the strokes to the show, the total strokes. So here at least three questions about the strokes. This is the first requirement. So there is three requirements. And also he asks about the initial mass and final mass. So the initial mass is during drilling and the final after killing the well. So also there is here two questions. And what else he asks for? He asks for the kill mud weight and the ICP and FCP. So 8 questions minimum are asked from you in this section, but it's plus or minus nine. So nine. The ninth one may be the schedule step down, the step down of the schedule. So take care of all these points. So the first one we will get is the initial mass, which means that the initial mass. Okay, as you see here, the formula gives you everything. You have no need to study the formulas or something like that. So it is C, which means C here is 16.9 minus the current mud density, which is 14. So you will put 16.9 minus 14 multiplied by show true vertical depth. Show true vertical depth. So multiply by 98.75 multiplied by 0.052. It will give you number. It's 1489 point something. I'm not calculating it, but you have to make round down to become 1489 as it is. Okay, no problem with this. So this is the first one, the first requirement. Okay. Okay, we will go after this. The bump one, as I told you here, this is the barrel per stroke or the bump displacement. It is 0.1 0.1019. Here, point 1, where is the pump data? Here is the pump data, 0.1019. So this is very vital question. Also here, and the stroke per minute, as I told you, this is 13. This is 13. Here, stroke per minute. And what is the pressure of this at this 13? It's 650. As I told you here, this is the 650 psi. So this is very important. We have both the pump data here. Sorry. Now, this is very important point. Very important point. And by the way, in the exam, you have to solve it twice. Why twice? Because at the first time, if you make some mistake, you have to avoid it in the second time. Okay? So that take care of these points. Here, the drill pipe, you don't know its length. He didn't give it to you. Here, he give you just the capacity of the drill pipe, but he didn't give you its length. But he gives to you the heavy wall drill pipe and the length of the drill collars here, as you see, so that you have to calculate both of them. How to calculate? Here, the drill collar is 88. This is drill collar, 88 feet. It's okay. And here the heavy wall drill pipe is 600. Here, where is heavy wall drill pipe? This is 600. So that what is the other in the drill string will be the drill pipe. So that here the measured depth. Take care the measured depth. Okay, if it is different than true vertical depth for sure. The measured depth here minus both of them will give you this number. So here you got the length of the drill pipe. Okay, this is very important issue. Okay, then what else? Take care about this. You have to put the capacity of the drill collar next to drill collar, and the drill pipe next to drill pipe, and the heavy wall drill pipe next. And so they are each one to the next of it. So take care here. The drill pipe capacity here. What is the drill pipe capacity here? It's 0.0174. Here I have to tell you something in order not to make mistake. Once you took the capacity of the drill pipe capacity, for example here, and put it here in its place, go ahead and with your pen and make mark over it. Cancel it. Don't see it again. Okay, in order not to make any mistake, each one you take, you have to make cross over it, or you have to eliminate erase it from the paper at all. Okay, this is very important. And the second one is for heavy wall drill pipe. Here the heavy wall drill pipe capacity is here, so we put it here also, and the drill collar we put its capacity here. So this is the inside capacity. So this means that this is the total capacity, okay, or the total volume that the mud can take from surface to the pit. And this is very important question. After you take the lenses and the capacities, you have to multiply each one next to each one, okay, like this, and put the volumes. As you see here, we took all the number, we take all the number, and we finally adding to each other, this one to this one to this one, and take the summation of all. Here's the total volume. This total volume is per barrel, and we need strokes. So we divide this total number by the pump displacement here. So it will give you the pump strokes from the surface to the pit. And this is the second requirement. So from the number of strokes from surface to the bed, this number. Take it and put it in the answer sheet. Okay. After finishing this, all of them are erased. Okay. So this is not here. This is not here, and also this is not here. They are. You will not see them. Okay. Go ahead. After this, take for example, this is the drill string volume. Here in the open hole. Open hole means from here to the show. To the show. Here, how to get it? How to get it? He gives you the drill collar length. Okay. So you put the drill collar with the open hole here. The drill collar length. It is the same. It's 880. It's 880 because it is the same. Okay, now the show here is 9875, and you will subtract from 11,053.6, so it will give you more than 888. Okay, in order to calculate for the volume, take care here of these lenses. The length of the drill pipe is equal to the show. So you put it here, the length of the drill pipe, okay, in the casing, which means in the casing, you put it here, next, it is in the show, it's the same like the show, okay, so you put it here. So now, how to calculate the length of the heavy wall drill pipe in the open hole? How you put it? It's easy. It's the measured depth, again, the measured depth 11,536 minus the measured depth of the 9875. It will give you a number minus the 880 minus 880. So it will give you the length of the heavy wall drill pipe in the open hole. So that's it. Okay, so here we got all the lenses. Take care that after finishing you have to make summation to those lenses, and they must be the measured depth here. Also you have to make the summation of those lengths, okay, and they must be the same that the measured depth here. Okay, if you put them and everything is okay, so I am guaranteed that you will be 100% answer the best answer and the right answer for the mod sheet, the kill sheet. Okay, this is the most important point in the kill sheet. Okay, what else? Here the drill color and what is the capacity in the open hole here, in the open hole annulus capacity here for against the drill color. So he gives it to you here, which is the capacity of the open hole and drill color. This number is put against it, and after you put the number, erase it or put cross over it or make mark over it. So it is 0.03221 here, 0.03221, and also by multiplying both you will get the value. Here the heavy wall drill pipe and the open hole. Here also the heavy wall drill pipe and the open hole. So it is 0.04470, 0.04470 barrel per feet. So now, and by multiplying this and multiplying this, you will get both the volumes, and by make summation to both volumes you will get the volume, which is the volume in the open hole volume of the open hole volume, and by dividing this volume by the mud displacement it will give you the number of strokes from the pit to the show. And as I told you, this is very important. This is very important in order to see the gas behavior before going to the show and to take care of the mass and the plus blah blah what we have talked about. So this is the second requirement, which is the number of strokes from the pit to the show, from the pit to the show. Okay. Number three, drill pipe and casing. As I told you here, also you will get the capacity of the casing and drill pipe. That's the third, three. And after you take also them, you make mark over it to in order to no not to choose it again, and you put here, and this is the volume of it. After finishing this volume, also take the strokes. Here he can ask you the question of the total annulus strokes, or the number of strokes from the bed to the surface. It's the same meaning. So here it is F plus G. F here and G here gives you H. What's H here is the total number here. And by dividing it over the bump displacement here, it will give you the total number of strokes on the annulus volume, which is here the total number of strokes in the annulus. That is the total number of strokes in the annulus. And this is the requirement number three. This is the requirement number three. Also may give you another question. What is the total time for full circulation? Which means here the total well system, which gives you the number D here plus number H here, it will give you the total volume, and by dividing with the bump displacement it will give you the total strokes in the system or on the well, and by dividing this number of strokes by 30 stroke per minute will give you the total number of minutes, and the number of minutes it can be rounded up, so it will be 240 minutes. 240 minutes. So this is the first paper in the kill sheet. You have already finished it, and this is number one question. This is one, this is two, this is three, this is four, This is 5. So 5 question multiplied by 3 marks, you have got the 15 marks from the first one. So you have to take care about this very well. Now, what is the kick data and what other data you will get? Here's a shot and drill pipe pressure. Shot and drill pipe pressure equals 530. Shot in casing pressure equals 700. Bit gain equal 10. And we will put all of them here. Okay, this is great. Now, what is the kill mud weight? What is the kill mud weight? There is here, he give you the formula. The current mud weight, which is 14, plus the shot and drill pipe pressure, 530, divided by the true vertical depth of the bit. True vertical depth here means the bit vertical depth, not the show. So the true vertical depth here is for the bit multiplied by 0.052. So it gives you, for example, 14.85, for example, but we have to round it up to the first decimal, just one decimal as you see here. So it will be 14.9. Okay. After calculating, and this is important, this is the sixth question, kill mud weight. You have to put it, okay? What is the ICP or initial circulating pressure? Initial circulating pressure means the dynamic pressure losses at the kill rate, which means 65, 650. As I told you here, this is 30 and this is 650. Okay, 650 plus the shot in drill by pressure. So plus the shot in drill by pressure. So the initial circulating pressure will be 1180 psi. The FCB or the final circulating pressure, and this is the sixth question, this is the seventh or the eighth, I don't know. The final circulating pressure is kill mud weight over the current mud drilling fluid density multiplied by the dynamic pressure losses. So here 14.9 divided by 14 multiplied by 650. So it will give you the FCB, and FCB must be rounded up. FCB must be rounded up. So it is 692. Those are the, until now we have finished, we have got all the question or the requirements. The last requirement is the final mass. So after the mud weight, we get the kill mud weight, which is 14.9. So we will go here. So it will be 14.9 minus 14 multiplied by the show depth here multiplied by 0.052. It will give you the final mass. So here you get the strokes from the surface to the bit, from the bit to the show, from the total annulus, and the time of the total circulation, the initial mass, the final mass, the kill mud weight, the initial circulating pressure, and the final circulating pressure. Here are the 9 requirements that is required from the kill sheet. Inshallah, you will get them well, and you have to keep in your mind that the training will make it easy for you to study well the kill sheet and be ready for the exam. Today it was very important lesson. Thank you very much, my friends, for this lesson. I hope this video is informative for you, and I hope it appeals to you. If this video appeals to you, please share, like, subscribe. It's your channel, not mine. And for any question in kill sheet, it's welcome, and I will answer for it on my page or another pages. Thank you very much. See you inshallah later in other issue. Thank you very much. We will talk tomorrow about the killing method. Goodbye.